I will start our meeting today to solve these two problems. Question number 3A and B. One of the question in the exam number 1 for last year. These problems are real problem from the exam. For the first one, in the swimming pool shown, determine the resultant hydrostatic force. Resultant hydrostatic force on surfaces AB, BC, and CD for a unit width of the swimming pool. One by one. Let's start one by one. I will start with surface AB. Here is the surface, point A, point B, and what is the pressure at point A? What is the pressure at point B? And remember, pressure due to water equal gamma time H. Because your dimension here are feet, so gamma water will be 62.4 pound per cubic feet. So go ahead and start. PA equal gamma water time 0. So the pressure at point A will be 0. We don't have H. We don't have height of water. B, pressure at point B. We have gamma water 62.4 time H. What is the vertical height of water above point B? 8 feet. So the value of the pressure equal 499.2 pound per square feet. So we have a value here, 499.2. We have a value here, 0. If you draw a line between the two values, you can represent the water pressure on this surface. Looks like triangle. But we need to sketch this pressure like I did. We need to sketch the water pressure distribution on each surface like I did. But we need to determine the resultant hydrostatic force. This triangle can be equivalent to this force F. F equal the area of this triangle 1/2 time 499.2 time this height, which is 8 feet. So the value will be 1,996.8 pound per unit width. Anybody remember what is the location of this force? Do you remember that from structure analysis? I believe this height will be 1/3 of the height of 8 feet. I am done. I am done with surface AB. I draw or I sketch the pressure distribution. I figured out the value of the resultant hydrostatic force. Let's do it with surface BC. I can do it here. For surface BC, do you remember the shape of the surface BC? It's a horizontal one. Here you go. Here is point B. Here is point C. What is the pressure at point B? What is the pressure at point C? Keep in your mind, any pressure equal gamma H. What is the H value? What is the height above point B? We have 8. So pressure at B equal gamma 62.4 times H 8 equal 499.2. Point C. What is the height above point C? Anybody knows? What is the height of water above point C? It's 8. So the pressure will be 62.4 times 8 also. Your value will be 499.2. That means we have a value here, 499.2. We have the same value here, 499.2. If you connect between the two values, we can get uniform distribution of pressure. So this is the sketch of the water pressure. Can anybody tell me what is the equivalent force here? F from structure analysis will equal this area of rectangle will be 499.2 times this total length. How much? 12 feet. So your final value 5,990.4. Any questions so far? Guys, do you have any question? Okay. What is the next surface? We are done with BC. What about CD? Here you go. CD is inclined surface. So, what's the name? CD. So, for surface for CD. Point C, point D. That's right. Okay. What is the pressure at point C? What is the pressure at point D? The height above point C will be 8 also, 62.4 times 8. The pressure value will be 599.2. The height above point D, what is the height here? Above point D, 3. Perfect. 62.4 times 3. So this value 187.2. Guys, remember and don't forget, pressure is perpendicular to the surface. Like I did here, this pressure is perpendicular. Like I did here, the pressure is perpendicular to the surface. We have inclined surface, so the value at C will be perpendicular like this, 499.2, and at D will be like this, 187.2. If you draw a line in between, your pressure looks like trapezoid. If you would like to divide this trapezoid to two parts, the first part is this rectangle with force F1. What is the value of F1? Equal 187.2 times this length. What is the length? This one is 8, this one is 5. So the inclined line will be 9.4 feet. So 9.4 is the inclined distance. Time 187.2 This force will be 1766. Don't forget, we have another triangle here. This little height will be 499.2 minus 187.2, 312. So the value for F2 equal 1/2 time 312 time 9.4, the length. This value will be 1466. I am done with part or surface CD. I draw the pressure distribution and I figured out the hydrostatic force. If you would like to get the total force, equal F1 plus F2 if you would like. Guys, do you have any question so far? Do you have any question? This one is one of the problem in the exam last semester, last spring, with 10 points. Any question? Okay. The second problem in the same question, this one, just for 5 points. We have 1.75 pound can of soda, Pepsi, or Coca with a diameter of 2.5 inch and a height of 5 inch. This can with diameter 2.5 inch and the height equal 5 inch, and this can has weight equal 1.75 pound. This can is placed completely in water. Can you tell me what is the buoyant force acting on the can? Do you think this can will float or sink? By the way, we have a container with water and I placed this can in the water. What is the buoyant force? F. Can anybody remember last meeting? What is the value of buoyant force? Equal gamma of this liquid time volume of this can. Gamma of the liquid, which is gamma water, time volume of the submerged can. Gamma water, I think it will be 62.4. What is the volume of the can? Anybody knows what is the volume of the can? It's a tricky. The can looks like a cylinder with diameter diameter how much? 2.5, and the height is 5 inch. We need to figure out the value of the buoyant force equal gamma time volume. So gamma equals 62.4. What is the value of volume? Any answer? Guys, any answer? What is the volume for this can? I believe if you ask anybody in probably middle school, he will or she will tell you that the volume of the cylinder equal the area of the base times the height. So the volume equal area of the base is a circle with diameter 2.5. So pi divide 4 times diameter square. This is the area of the base, area of circle. This area of base will be multiplied by height, 5-inch height. This number will be the volume of the cane. Do you agree? If you agree, say yes. If you don't agree, say no, and what is the reason? Yeah. Volume, how much? 24. 24.54. 24.54. And this value will be 24.54. One more time. Do you agree with this number or you have a different number with your calculator? So Benjamin said yes. Melvin said yes. Any other answer? We have Anthony, Clayton, Marcus, Zach, Miguel. Do you have any? That's correct. I agree. Guys, we have your calculation looks good, but we have a little mistake here. And this mistake is a fatal mistake. Gamma of water, which is 62.4, is bound per cubic feet. And this volume, these dimensions are given in inch. So area of base will be inch square, height will be in inch, the volume will be inch cube. So this value 24.54 in inch cube doesn't make sense to multiply a unit bound per cubic feet by another unit inch cube. Your units must be consistent. Your units must be consistent. So we need to convert from inch cube to cubic feet. So I'm gonna divide this number by 12 cube. Why? Because 1 feet equal 12 inch. If you would like to get 1 inch, you have to divide by 12. So this number in inch, I need to divide it by 12 to get it feet. However, we have 1 inch cube. So you need to divide by 1, divide 12 cube to convert from inch to feet cube. So the only mistake here, this number must be divided by 12 square. That's it. This is the only mistake. So your value will be 62.4 times 24.54 divide 12 cube. This value equal 0.886 pound. So the point force from the liquid equal 0.886 pound. However, the weight of the can equal 1.75 pound. Do you think this can will float or sink? I believe the can will sink because the weight greater than the point force. Does that make sense? Thank you. Thank you. Okay. So most of the students did this one in the same way, but they forget to convert from inch cube to feet cube. So do you think the exam will be hard or will be normal? Will be normal. We covered all of this stuff during the homework and during the live meeting. We covered this stuff during the homework and the live meeting also. The only trick here is the conversion between units. You need to pay attention to units a little bit. Last thing I need to cover for this part or this topic, we have something called absolute pressure. And we have something called atmospheric pressure, gauge pressure, vacuum gauge pressure. What is the meaning of this? Okay, let me explain something for you here. If you have a tank filled with water, what is the pressure at this point? If you said this pressure at this point equal gamma H, we have H and we have gamma for this liquid. That means if you multiply gamma H, you can get the pressure. Actually, this pressure can be called gauge pressure. I'm sorry, what you mean? I mean, we have air above the surface, and the air has pressure, which is called atmospheric pressure. Atmospheric pressure, the weight of the air. This atmospheric pressure is equivalent to 76 centimeter of mercury or 29.92 inch of mercury or equal 14.7 pound per square inch psi, 33.9 feet of water, or equal 1.013 times 10 to power 5 Newton per meter square. The value of the atmospheric pressure can be measured using any of these quantities. If you add this atmospheric pressure to this gauge or calculated pressure, the value will be called absolute pressure. Absolute pressure. So absolute pressure will equal the atmospheric one plus the gauge one. The gauge pressure equal gamma H. The atmospheric pressure is given in these values. Guys, by the way, What is the meaning of atmospheric pressure equals 76 centimeter of mercury? What does it mean? Atmospheric pressure equal 76 centimeter of mercury. If you have mercury, this liquid with height 76 centimeter, the weight of this column of liquid of mercury equivalent to the atmospheric pressure. Okay? One more thing. Sometimes the pressure can be measured by pound per inch square. This can be called PSI. It's very important to understand these concepts. You are junior student, next year you will be senior student, then you will be graduated. So you need to understand these terms. Pound, if you have a force in pound and this area in inch square, so if you divide this force by this area, your units will be pound per square inch. This can be called PSI. Sometimes the force in kip, and you divide it by inch square, so the value or the unit for the pressure or the stress equal kip per inch square. This term can be called KSI. Kip per square inch. Pound per square inch. PSI. By the way, you should understand, you should know this relationship. Kip equal 1,000 pound. Please keep this information in your mind. Kip equal 1,000 pound. What is the meaning of PSI? What is the meaning of KSI? Any question? Okay. I have question here. Example number 1. The first one, the first part in this example is piece of cake. What is the pressure at 10 feet below the surface of a swimming pool? Here is the surface of the swimming pool. Under this surface by 10 feet. What is the pressure? Pressure equal gamma H. Because you are talking about feet, so gamma equals 62.4 and H equal 10 feet. So the value will be 624 pound per square feet. For this one, we need to figure out the water pressure the pressure at the bottom of the tank. We have water with height 2 meters, and then we have gasoline with height 3 meters. Can you tell me what is the pressure at the bottom of the tank? I believe the equation will be used pressure equal submission, gamma H. Do you remember that? We covered this before. If you have many fluids and you are looking for pressure at this point, so you need to get gamma H plus gamma H plus gamma H, every liquid above this point. So let's start with the water. Gamma water time H 9,810 gamma water time height of water 2 meters plus gamma gasoline time H gasoline 3 meters. You can get the final answer. My question is, do you think gamma gasoline is given? It's not given. The gasoline, what's given is specific gravity. So we need to do something. Specific gravity for any liquid equal gamma of this liquid, gamma gasoline, divide gamma water. Do you remember that? So specific gravity is given by 0.73. Gamma gasoline, I'm looking for it. Gamma water, 9,810 Newton per cubic meter. That means gamma gasoline can be 0.73 times 9,810. This value will be 7,161.3 Newton per cubic meter. So I'm gonna use this value here. 7,161.3. So the final pressure will be 41,103.9 Newton per square meter. So guys, right now, you can solve the homework number 3, only 3 problems. And we covered everything in this module or this week. So we will start a new topic next week on Tuesday.